All right, so I'm going to look at one of these examples, one of these quite kind of practical examples which come up on the exam from time to time, where someone has kind of a target amount they want to receive as their pension, and we need to figure out how much would it cost to buy the annuity that will pay out that level of pension for a certain number of years, and then how much will someone need to save every month or every year to fund the purchase of that annuity when they do retire. So first up is the annuity and the pension. So Bort wishes to receive a payment of €25,000 annually from when he retires at 65 until he is 85. How much money will he require on his 65th birthday to purchase this annuity? Assume a 5% AER. So we are purchasing some annuity when he's 65. So when he's 65, this annuity is going to cost an amount of money. 25,000 annually from when he retires. So I would interpret that as he receives the first 25,000 straight away. So like the annuity is purchased and then straight away it pays out a 25,000 and then a 25,000 every year. So the annuity when he turns 65 is going to cost the present value of the 25,000 he receives straight away. Don't need to discount that. Plus, in a year's time, he's going to receive another 25,000. But because that's in a year's time, it's not worth as much in today's terms, so I discount it by 5%. And then in another year's time, I receive another 25,000. Because that's in 2 years' time, I'm going to discount it twice. Until when he is 85, he's going to receive another €25,000. And now that's in 20 years' time, but just the first one isn't discounted at all because I'm receiving it straight away. So this one, because I'm receiving it at the start of the period, is only going to be discounted 19 times. So I'm receiving it at the, so that's power of 19. So 1.05 to the power of 19. So because I'm receiving it at the start of the 20th year, just the end of the 19th year as well, it's only been discounted 19 times. So there's 20 terms in the series, but the last one has only been discounted 19 times. Just watch out for that slight mismatch between your N when we come to the series and what you're discounting. So we've got a geometric series here, and our first term in it is 25,000. And what am I multiplying by to get from term to term? What's my OR? Well, it is 1 over 1.05. So 1.05, then power 2, then power 3, etc. until power of 19. So that is my OR. So I'm going to do my SN formula. So SN is equal to A on 1 minus OR to the N over 1 minus OR. So for me, this is S20. That's equal to A is 25,000 on 1 minus OR is 1 over 1.05 to the N, so that's 20. All over 1 minus OR, so over 1 minus 1 over 1.05. Okay, so the cost to purchase the annuity is the present value of all future cash flows coming out of it. So if I work this out in the calculator, 25,000 multiplied by 1 minus 1 over 1.05 to the power of 20 is equal to that divided by 1 minus 1 over 1.05. So 327,133. We'll go to the nearest euro here. So 327 133. So for €327,133, he's going to receive 25,000 a year for 20 years. Okay. Now, the second part of the question. So this is about when he hits retirement. So he's turning 35 soon and will start saving for his retirement when he hits 35. How much will he need to save each month to afford the annuity on retirement at 65, assuming AER of 4%? So if he wants to buy this annuity paying out 25,000 a year for 20 years, he's going to need €327,000, 133, when he hits 65. So I'm trying to figure out between 35 and 65, how much is he going to need to put away every month so they'll afford this when he hits 65. So the first thing with this question is I've got an annual rate of 4%, so I need to change that to a monthly rate. Okay, so 1.04 is my annual rate to the power of 12, the power of 1/12, sorry, to make it monthly, and then just subtract 1. So 1.04 to the power of 1/12 is equal to that, and then take away 1. So 0.00327. Doesn't say, but I'm going to go up to 3 significant figures here. In an exam question, you hope that they might make this monthly rate maybe a separate part of the question, and they'll tell you an exact number of significant figures to go to. But I would say 3 or 4 if they don't say. So I'm going to 3 here. So that is my monthly interest rate. So I want to save a certain amount of money every month at this interest rate that will grow into this amount of money. Okay, so 327,133 is equal to you can use A again, or you can use S, or you can use kind of any letter that you want. I'll just use A again as the amount I'm saving. So when he turns 35, he's going to put some amount in the bank or in some sort of savings product. It's going to earn this much interest, so 1.00327, and then he is saving from 35 to 65, so he is saving for 30 years, so just by 12 is equal to 360 months. Okay, so that's how long that amount is going to be in the bank. So some amount saved at this rate for 360 months. The following month then, he's going to save the same amount of money. It's going to earn that amount of interest. This one's only going to be in the bank for 359 months. Until at the start of the final month, so 1 month before he hits 65, he's going to save one last amount of money. It's going to earn that much interest, and it's only going to be in the bank for 1 month. Okay, so again, maybe the question should be a bit more specific, that how much we need to save at the start of the month, but just reading it that he's going to start saving when he hits 35, I assume that's happening at the start of the month. So he's not going to put an amount in at the end when he hits 65. So the last saving is at the start of that final month. So I think the best thing to do here on the right hand side is to factorize that A out, that amount that he's going to save, because then what I'll be left with after I factorize that out is a series, and it'll just be easier to deal with if you have the A factorized out. So the 327 is equal to A, because it's going to be common to every single term, the A, so I'm just factorizing it out. Now, at this point, you've got a choice. You can start your series with 1.00327 to the 360, and then 359, and then run it all the way to 1.00327 to the 1. Or you can flip your series the other way around, just so you won't have to deal with fractions in your series calculation. It's much of a muchness when you're doing it on the calculator, to be honest, but I'll flip it around just because you'll see that done sometimes. So because the series is being added together, it doesn't matter which way I run it, from start to finish or from finish to start. So I'm going to start with the 1.00327 to the power of 1, and then the second last one would be 1.00327 to the power of 2, all the way until I've got 1.00327 to the 360. So 327,123 is equal to A times this. So inside that square bracket, then you've got a geometric series. So your first term A is just 1.00327. And what are you multiplying by to get from term to term? It's 1.00327. The power is just increasing every time. That's the only thing you've got left in this series, is because you factorized all the A's out, you're just left with the 1.00327. So it's increasing every time. So that's the OR. If you didn't run the series the other way around, if you left it as 360, 359 all the way to 1, the only difference it would make would be your first term A would be 1.00327 to the 360. And then because your power is decreasing every term, if you ran it that way, your OR would be 1 over 1.00327. So that would be power 360. This will be 1 over. It doesn't matter. Your answer, when you put it into the S formula, will be the same. Okay, so I've got my formula over here. So I'm doing S 360 is equal to A, my first term, so 1.00327 on, so the N here should be inside that, sorry, the N should be inside the bracket there. So 1.00327 on 1 minus my OR is 1.00327 to the power of 360. Over 1 minus OR, so 1 minus 1.00327. So just put that into the calculator. So 1.00327 multiplied by 1 minus 1.00327 to the 360 divided by 1 minus 1.00327. So that's 686.96. I'm gonna just use this number when I bring it over, divide it, so it doesn't matter if I round it or not. Grand. Now, this 686 doesn't really mean anything because you factorize the A out. It is just what is inside this square bracket. So just to put this back together again, the 327,133. So the target amount you want to save is equal to A, the monthly amount, multiplied by the 686.96. So I'm just going to bring this over and divide it into the 327,133. Okay, and then that's going to give me my A, the amount I need to save every month. So bring the 686 over. So 327,133 divided by 686.9632,112 is equal to A, so equals the amount I'm saving every month. So 327,133 divided by the answer I got there is 476 and 20 cent. So there's your monthly saving. So Bort turns 35. He starts saving, 476 euro per month for 360 months for 30 years. If he's been saving that every month and it's been earning 4% interest, it has grown to 327,000 euro 133. He'll be able to use that to purchase an annuity then, which will pay him a pension of 25,000 euro a year for 20 years.